Hello, ladies and gentlemen, and welcome. Had a few recent comments, and those comments have led to what you are looking at right here. One of those was in regards to diamond bricks, which I have a very nice example of, but it reminded me that, when I moved in my home several years ago, that I had inherited basically several shards of bricks and a few whole bricks, one of them being a diamond, which until recently I didn't even notice. I've been using these things as weights, and you can see that the diamond there on the bottom right side has a bunch of white paint on it. So I'm going to try to strip all the paint off of that brick, but I wanted to show you guys just a few things that I found around my home. And until I acquired the eyes that I have, these were just normal random bricks that I found either in the garage or, out in the yard. A couple of these I actually have used for some of my landscaping because I was like a half brick short. But anyways, figured I'd give you a quick view of these. The evidence is everywhere. It doesn't matter where you are. Um, Also, the other comment, David Wayne, we were discussing the fact that we have never found a perfect brick, that's obviously an old brick. They all seem to be heat damaged or deformed in one fashion or another. And by the way, I don't have any association with any clubs. That includes any eye clubs or pyramid clubs or hair clubs. Brick here, front and center, I actually used as a grave marker for my kitty cat. And it is the most cooked out one of all of these. But we're going to take a quick look. I won't spend a ton of time on these. Hopefully I can get the paint stripped off of the diamond without damaging it, and I can show you the results of that.
Alright, before we get started, thought I would do a little looking into bricks, and I'm going to share my findings with you guys. I'm on this storables.com under this building materials section. What temperature can brick withstand? And this was published in January of 24. When it comes to building materials, brick has long been a popular choice for its durability, aesthetic appeal, and versatility. Whether used in construction for homes, commercial buildings, or outdoor structures, brick offers a timeless charm and robustness that withstands the test of time. However, a critical aspect of evaluating the sustainability of brick for various applications is understanding its ability to withstand high temperatures. In this article, we will delve into the factors influencing the temperature resistance of brick, explore the maximum temperatures it can endure, and examine the effects of exposure to high temperatures. By gaining insight into these aspects, you will develop a deeper appreciation for the resilience of brick as a building material and its potential limitations in extreme heat scenarios. Few key takeaways: brick can withstand temperatures up to 2000 degrees Fahrenheit, making it a reliable choice for construction. However, prolonged exposure to extreme heat can lead to color changes, cracking, and loss of strength. Factors like composition, firing technique, and porosity influence brick's ability to resist high temperatures. Understanding these factors helps builders make informed decisions for various construction applications. Factors affecting temperature resistance of brick. Brick, a time-honored building material, exhibits varying degrees of temperature resistance, influenced by several key factors. Composition. The composition of the clay used in brick production significantly impacts its ability to withstand high temperatures. High-quality bricks are typically composed of dense, well-fired clay with minimal organic impurities, enhancing the resistance to heat. Firing technique. The firing process plays a critical role in determining the brick's thermal resilience. Bricks subjected to high-temperature kiln firing undergo vitrification, a process in which the clay particles fuse together, resulting in a denser and more heat-resistant material. Porosity. The porosity of a brick, determined by its internal structure and the presence of microscopic voids, affects its thermal conductivity and resistance to heat. Lower porosity generally indicates higher resistance to temperature fluctuations. Chemical additives. Certain chemical additives, such as alumina and silica, can be incorporated into the brick's composition to enhance its thermal properties, increasing its ability to withstand extreme temperatures. Manufacturing standards. The adherence to stringent manufacturing standards and quality control measures ensures that bricks are produced with consistent density and structural integrity, contributing to their overall temperature resistance. Understanding these factors is essential for assessing the sustainability of brick in environments where high temperatures are a concern, whether used in fireplaces, industrial furnaces, or exterior facades exposed to intense sunlight. The composition and characteristics of the brick directly influence its performance in varying temperature conditions. Maximum temperature brick can withstand. Brick, renowned for its robustness, demonstrates impressive resilience to high temperatures, making it a favored material in applications where heat exposure is a consideration. The maximum temperature that brick can withstand is influenced by its composition, density, and firing process. Generally, standard clay bricks can endure temperatures ranging from 1800 to 2000 degrees before exhibiting significant structural changes or failure. For specific applications requiring even higher temperature resistance, specialized refractory bricks are available. These bricks, engineered for exceptional thermal stability, can withstand temperatures exceeding 2700 degrees and are commonly used in industrial fireplaces, kilns, and high-temperature processing environments. It is important to note that while brick exhibits remarkable resistance to heat, prolonged exposure to temperatures at or near its maximum threshold may lead to gradual deterioration. Factors such as thermal cycling, mechanical stress, and chemical reactions in high-temperature environments can contribute to the degradation of brick over time, necessitating careful consideration of its limitations in extreme heat scenarios. By understanding the maximum temperatures that standard and refractory bricks can endure, builders, engineers, and architects can make informed decisions regarding their use in diverse applications, ensuring the longevity and safety of structures exposed to elevated temperatures. Effects of high temperatures on brick. When subjected to high temperatures, brick undergoes a series of physical and chemical changes that impact its structural integrity and appearance. Understanding the effects of elevated temperatures on brick is critical for assessing its performance in environments characterized by heat exposure. Thermal expansion. High temperatures cause brick to expand, which can lead to stress within the material. While brick is designed to accommodate thermal expansion to a certain extent, prolonged exposure to heat can result in micro-cracking and gradual deterioration of the material's mechanical properties. Color changes. The color of brick may undergo alteration when exposed to high temperatures. This is particularly evident in the case of clay bricks, where the firing process initially determines their color. Prolonged exposure to heat can cause the brick surface to darken or develop a metallic sheen, altering its aesthetic appearance. Spalling and cracking. Intense heat can lead to spalling, a phenomenon in which the surface layers of the brick flake off due to thermal stress. Additionally, the expansion and contraction induced by fluctuating temperatures can result in the formation of cracks, compromising the structural integrity of the brick. Loss of strength. Prolonged exposure to heat temperatures can diminish the compressive and flexural strength of the brick, affecting its load-bearing capacity and overall stability. This reduction in strength may compromise the safety and performance of structures constructed with brick in high-temperature environments. Chemical changes. High temperatures can induce chemical reactions within the brick material, leading to the breakdown of mineral components and alteration of its physical properties. These chemical changes can contribute to the degradation of the brick over time, particularly in environments with aggressive chemical agents or high-temperature combustion byproducts. And there's a little conclusion here, which basically just goes over everything that we have read, so I'm not going to read that. Frequently asked questions. The top question here: how hot can bricks get before they start to melt or break? Bricks can withstand very high temperatures, typically up to 1800 degrees Fahrenheit, 982 degrees Celsius, before they start to soften or deform. However, the exact temperature can vary depending on the type and quality of the brick. And I just wanted to look into this. I wanted to credit the author here, if I could, for putting this little bit of information together for us. I'm not seeing a name again. But anyways, one more little thing I want to show you guys, and then we will move on to the video. Well, if you're still here, you might be a little bit of a nerd. Hopefully I didn't lose everybody, but I just wanted to look into a few things that are brick related with you guys. I'm on this brickcollecting.com. Brick making in the USA, a brief history. The first bricks in the English colonies in North America were probably made in Virginia as early as 1612. Probably would indicate that they don't have a clue when the first bricks in the English colonies were made. New England saw its first brick kiln erected in Salem, Massachusetts in 1629. The Dutch colonists in New Amsterdam imported yellow bricks from Holland, which imparted a Dutch character to the architecture of the city. The excellent quality and abundance of local clays in the colonies made it unnecessary to import bricks from across the Atlantic. Brick-making centers developed in Fort Orange, what is now Albany, New York, near Philadelphia, Pennsylvania, and Burlington and Trenton, New Jersey, as well as along the Raritan River. Preface. There are three processes used in making bricks: varying primarily in the amount of water mixed with the clay. Stiff mud extruded. In this process, used for most building bricks, only enough water is added to the clay to make it into a stiff paste that can be extruded through a die into a long ribbon or column of clay. The clay is sliced into brick-sized chunks by the brick cutter, a machine with a series of cutting wires. A vacuum pump may be used to remove air from the clay to make it stronger and easier to handle. Dry pressed. In this process, the clay mix is only dampened. The clay is then compressed under high pressure into molds. This method is used for face and refractory brick. Since there is little water in the mix, the bricks can be fired without long drying periods. Soft mud. In this process, more water is used to make a soft paste of clay. Molds are dipped in sand or water to prevent sticking, and the paste is pressed in place and then allowed to dry. This method is used for all handmade bricks and is the method we will focus on in this history. How bricks were made with the soft mud process from the mid-1800s to the early 1900s. Preparing the ingredients. The main ingredients were clay and sand and shale. The clay was dug from the shore or from under bodies of water, such as the Hudson River. Beach sand mixed in very well and improved the quality of brick. But in some places along the Hudson, there was up to 12 inches of oyster shells laying on top. These had to be removed. 12 inches of oyster shells? That's incredible, as the chemical reaction from the slaked lime would crack the brick. The clay had to be dredged in early spring or late fall to allow time for seasoning, and all the water had to drain off. Next, the clay was screened to remove rocks, and the shale and the clay were ground into powder by the crusher and stored. Here, a team of mules and horses is being used to haul a two-wheeled scraper to a platform where the clay powder was dumped into small, side-dumping rail carts called dinkies, which were pulled by cables or small locomotives. The powder was brought up to the pug mill via a long incline as seen in the far right here at the Leonard Brick Factory in Delton, Michigan. In the pug mill, water was added to the powder and the clay and sand mixture was soaked, stirred, and kneaded with large augers or wooden paddles until doughy. This step is called tempering or pugging and was the hardest work of all. In the mid-1800s, horse-driven pug mills were invented. The clay was removed from the soaking pit or pug mill by a temperer who delivered it into the molding area. And you know what cracks me up, guys? I mean, we've seen the buildings that have been built with bricks, and yet here we are in this freaking shack. This is where we're producing the bricks for these amazing structures. Does that make any sense whatsoever? Not to me, it doesn't. But moving on to the molding. Note the brick mold being held by the lad on the left. These are some of the Leonard Brickyard employees. George Leonard is second from the left. Ah yes, the brick mold. Before the invention of steam-driven machines, bricks were molded by hand. A great description of this is on the website Rick's Bricks. The assistant brick molder was called the clot molder, and he would prepare the lump of clay and give it back to the brick molder. The brick molder was the key to the operation, and he was the head of the team. He would stand at the molding table for 12 to 14 hours a day, and with the help of his assistants, could make 3,500 to 5,000 bricks in a day. With these hand molds, that is pretty impressive. He would take the clot of clay, roll it in sand, and dash it into the sanded mold. The clay was pressed into the mold with the hands, and the excess clay removed from the top of the mold with a strike, which was a flat stick and had been soaking in water. This excess clay was returned to the clot molder to be reformed. Sand was used to prevent the clay from sticking to the mold. So if my math is correct, going off of a 14-hour day, assuming you've produced 5,000 bricks in those 14 hours, that would be around 357 bricks an hour. Single, double, 4, or 6 brick molds were used. The single brick mold had an advantage in that a child could carry it to the drying area. Oh, yes, what an advantage that they should have children working for them. Beechwood was the preferred material for the mold, for it was claimed that the clay would not stick to it. The top of the mold was laminated with iron to prevent wear. The brick slid easily out of the mold because it was sanded, and these bricks were referred to as sand-struck bricks. The process was also referred to as slop molding. The next person on the team was called the off-bearer. He would walk up to the molding table, remove the filled mold, and take it to the drying area on a pallet or barrow where it would be placed on a level bed of sand. He would then return the mold to the table, wet and sand it to receive the next brick. Over the years, a few rudimentary tools were introduced to help streamline production. In 1830, Nathaniel Adams of Newborough in Cornwall, New York, invented a molding machine. However, this required human and animal labor to operate. The real breakthrough came in 1852 when a steam-powered machine was developed by Richard Varvailin. Scroll down for a complete section on this significant invention. Alright, and we are looking at the Chambers brick machine here, guys. Check it out. We are making some bricks! And it's a little mysterious to me exactly how they got the horse and cart up here on the second level, but other early brick-making machines like this one, patented in 1863 by Cyrus Chambers of Philadelphia, used stiff mud which was forced out in long ribbons on a conveyor belt, transferred to molds, and cut by a revolving cutter. As time progressed, up to 25 bricks could be cut at a time. The bricks were then stamped with the appropriate name or design. Drying the bricks. 4 crews of 2 workers stacked the brick on kiln carts or brick buggies, and when the carts were loaded, other crews put the bricks in the dryers. Several types of dryers were available: dryer sheds, dryer tunnels, and drying yards. Dryer sheds were located within the factory. These were rooms with large fans run by steam engines at each end of the shed to dry the brick. Dryers had to be kept at a constant temperature. Tunnels were also used for drying. These dried bricks were called green brick. 80,000 to 100,000 green bricks were manufactured in a day. Inside of the drying shed, the bricks air-dried prior to firing, turning bricks so they rest on edges and dry evenly. Haverstraw, New York. Again quoting Rick's bricks, for yard drying, the molded bricks were stacked in the herringbone pattern to dry in the air and sun. The molded bricks were first left to dry for 2 days, at which time they were turned over to facilitate uniform drying and prevent warping. During this time, tools called dressers or clappers were used by the edgers to straighten the bricks and obtain a smooth surface. After 4 days of dry, hot weather, the bricks were sufficiently hard to allow them to be stacked in a herringbone pattern with the fingers width between them to allow further drying. This area was called a hack or a hackstead, and the bricks were covered under roof or with straw to protect them from the rain or harsh sun. After 2 weeks, the bricks were ready to be burned. George V. Hutton, a descendant of the founder of the Hutton Brick Company in East Kingston, New York, describes the drying yards at the Hutton factory. They consisted of 10 inch of gravel for drainage, then 6 to 8 inches of blue clay on top, then 3 inches yellow clay on top that, and finally a coating of sand to keep the bricks from sticking. The beds were rolled flat and the workers had to remove their shoes. It would take 3 days of drying before the bricks were ready to be moved to the kiln. Right, finally starting to get a little juicy here. Burning the brick. The bricks were arranged into arches and the fire built inside the arch. The bricks themselves were the kiln. If fired bricks were on hand, they were used to construct the outer walls of the kiln, and the surface was daubed with mud to contain the heat. If no fired bricks were available, the kiln was constructed entirely of green or raw bricks, which were stacked in such a way as to act as their own kiln. These kilns were called clamps or stove kilns. Some coal dust was added because it made them burn better, and some companies added red oxide for coloring. Some didn't. The walls at the top were plastered with a mixture of sand, clay, and water to retain the heat. The top of the bricks were placed close together and vented for circulation to pull the heat up through the bricks. The kilns were originally fired with wood. Then some used anthracite coal, and some eventually used oil. Even after drying in the air, the green bricks contain 9 to 15% water. For this reason, the fires were kept low for 24 to 48 hours to finish the drying process, and during this time, steam could be seen coming from the top of the kiln. This was called water smoke. Imagine that, guys, steam called water smoke. How fitting. Once the gas is cleared, this was a sign to increase the intensity of the fires. If it was done too soon, the steam created in the bricks would cause them to explode. Intense fires were maintained in the fire holes around the clock for a week until temperatures of 1800 degrees Fahrenheit were reached. The knowledge and experience of the brickmaker dictated when the fire holes would be bricked over, and the heat was allowed to slowly dissipate over another week. The brick were baked from 8 to 12 days. Each finished brick weighed approximately 8 pounds. Salt was added to the kiln eyes while the brick baked. This changed their color and made them waterproof. When the bricks were sufficiently fired, the heat was reduced and they were allowed to cool gradually before removal from the kiln. Then the entire kiln was usually disassembled and the bricks were sorted. If only raw bricks were used, the bricks from the outmost walls were kept to be burned again in the next kiln. The bricks from the outmost walls were kept to be burned again in the next kiln. Some bricks which were closest to the fire received a natural wood ash glaze and sand that fell into the fires and became vaporized and deposited on the bricks. These bricks were used in the interior courses of the walls. Bricks that became severely overburned and cracked or warped were called clinkers, and those were occasionally used for garden walls or garden paths. The best bricks were chosen for use on the exterior walls of the building. Those that were only slightly underfired had a salmon color, and early bricklayers knew that the porosity of these bricks would help to insulate the structure. They were placed on the innermost courses of the wall. And finally, guys, I hope you're not bored out of your flippin' skulls. Number 5, transporting the brick. The brick was removed from the kilns on brick buggies or kiln carts. Approximately 8,100 bricks could be removed at a time. The men worked in pairs. One man would toss the brick from the kiln to the second man, who would load the buggy. The brick was then stored in large stacks, called hakes, out in the open. At full production, the amount of brick produced each month equaled 1 million. 1 million bricks a month is what they're claiming here, with one man casually tossing a brick at a time to another man while loading up the brick buggy. Sometimes there were as many as 5 month's inventory before all the bricks were shipped out. 80,000 bricks were shipped per day. Each railroad car contained from 8,000 to 10,000 bricks. The railway cars were loaded by hand with the brick buggies. 2 men could load a car in one day. Other yards shipped finished brick via schooners or barges. Astoria, Queens was a major distribution center for the New York City area. And I missed the opportunity in my last video to showcase the eye that I painted. A little bit of a mixed media, but it would have matched well with the eye that was in that tunnel that we looked at. But check it out, guys. I got the diamond brick cleaned up. All it took was a little bit of paint stripper and a $2 trip to the car wash.
The beautiful red inside of this. Interesting little spot right here. It still has some mortar on it. Next one is my poor kitty Autumn, R.I.P. This one I used for her grave marker. She is lovingly buried in my backyard under a massive tree, actually nestled between two gigantic roots. Look at this thing, guys. Pretty sure I found this. This was in the garage when I moved in. And the diamond, couple of the half bricks were behind or on the side of the garage. This one has some funky stuff going on. Obviously, I've decorated it. And that is the color that it is. You can see where the red has gone away at some point, or during whatever happened to this brick. Awesome spot right there. And again, I just thought that I like pyramids. There's nothing to that for anybody that wonders. It's an interesting, not sure if that's mortar in there or what. It's kind of soft. But let's see here. Throw one of these in the mix with all these funky lines. Looks like it was shrunken or squished. These sides are really shiny. Apologize for the dog. She thinks that she's a guard dog. She is a guard dog, but she hears and sees all. Those cracks. And take a little gander at this one. This is another one of those that has a super bright orange underneath. This has some funky green going on. Alright, I actually cut that because I was going to show you guys the dog. She can lift the blinds up with her nose to look out. It's funny. But she stopped doing that when I was ready to film her, of course. I'm going to go ahead and just go through these real quick. This is another one with these funky little, whatever that is, texture. Looks kind of squished. Super bright orange. So there's a couple interesting lines going through. Look how bright that is. This one's pretty light as well. And I might break out the scale on a couple of these in a minute. I don't think any of these are gonna float Kitch. I mean, some of them are pretty light, especially the one I found the other day. But I don't think they're light enough to float. But I've got a couple that are very similar. I found in different places. I can compare the weights of them. Looks like ground beef, y'all. And this one I did not bother cleaning the paint off of because I don't care about this one. Hold on, let me get some of this out of my way here. And this is another one of these super bright orange ones on the inside. And I might actually use this one to compare the weight to the one that I found a few days ago, because it looks like a similar brick as far as the size and makeup of it. Funny, I've been using ruins this whole time. not even realizing it. I wasn't able to get this video out as soon as I wanted to. I've actually gotten a few more boots on the ground explorations in between all of the rain that we've had. Some previous things I might have said in this video might be a little bit out of context. Anyways, these items you're looking at right here are from my exploration yesterday, which was Sunday. We're gonna take a quick look at these, then I'm gonna wrap this up. I had planned on actually doing a few other things like weighing some bricks, which I don't know if anybody even cares, but they said that the average weight of a brick was around 8 pounds, I believe, for your standard run-of-the-mill brick. All right, we're gonna start with this bottle here, and I actually was reading this incorrectly. It says tabbers, not tablets. So I apologize for that. And this is actually a company that is still around today. They started in 1936. And by the way, if you ever have to clean a piece of glass, CLR is your best friend. I just discovered that. But so I actually found an exact bottle to this on eBay with the surviving cap. And it is said to be a gasket sealer. They make automotive products. Can't really... Trying to get you, it has some of that rainbow color to it. You can see a little bit of it. But anyways, not old world, but pretty cool. What else here? And this is the brick that I pulled out of the side of that quote-unquote creek. All right, guys, we're here. I should have recorded me coming through this mess, but what have we here, guys? I wanted to do this with you. Just a brick hanging out in the side of whatever this cluster is right here. And this has some really cool colors going on with it. Couple different oranges. Look at that crack. But these purples right here, I call it plum. It's more of a plum to me, but I see this quite a bit. Some mortar in here somehow. A little chunk. This is the most red part of this whole brick. It's almost wedge shaped now. I noticed this same pattern on only one side of these quite a bit. This has kind of a bulge going through the middle right here. It's hard to see. And this, I guess you would call this a rock. It's got some interesting things going on. Particularly this thing here. I don't know what is going on with that. The shape of this actually reminds me of something, but I can't really put my finger on it. It's really weird how it has that, I don't know, that little nub. Almost looks like it's supposed to be there, but I don't know. Something interesting there as well. I don't know. I thought it was cool. I think it's a piece of melt myself, but and last but not least here, I pulled this off of that bizarre wall.
Climb up on this rock here.
That is surrounding Center High School. Looks like an ancient destroyed wall to me. But I wanted to just try to get a closer look at it. It was really strange material. As you can see, this is sparkly. Whatever that is. Maybe it's a piece of crystal or something. Looks kind of scaly. I got a magnifying glass. I don't know if it's gonna help any with the phone here. We can try it. Try to keep the glare out. Actually kind of works. little bit of a glare, but in the corner. And this was the underside. This was the exposed side that we were looking at. Anyways, guys, if you're still here, I really appreciate you. Imagine most people probably got to split my videos up in 2 different viewing sessions. They get kind of long. All right, well, okay, here we go. Ba-ba-da-ba-ba-ba-da-ba-ba. Still recording. Trying to get the best light. Alright everybody, I think that is going to wrap this video up. Hope everybody enjoyed, and I will see you on the next one.